Okay, in this video we are solving equations with brackets. To start off with, I do have a recap going over how to solve an equation, but then I do have a few examples with brackets for us to work through. So, first thing to be aware of was that whenever you see this word solve, that is telling you to find the value of whatever letter you are given in the equation. So whatever bit of algebra you have, you need to try and find the value of it. So for the first one, we have 2x minus 3 equals 11. To find its value, we need to get x on its own. And so to do that, first we need to deal with the other numbers that are going on around it. So first we looked at anything that's being added or subtracted. We have a negative 3. And to get rid of that, we want to do the opposite of the sign, and then whatever that number was. So negative 3 add 3 will give us 0, so that's going to cancel it out. If we do something on one side, we have to do the same thing on the other side. So we've now got 2x equals 14. Remember, 2x means 2 times x. Opposite of times is division. So I'm going to divide by 2 on both sides. So I now have x equals 7, because 14 divided by 2 is 7. And I prefer writing my divisions like this as a fraction because sometimes it won't fully simplify down to a nice whole number. Alright, so next one I've got x plus 6 equals 29. Now, easy mistake to make is that people see this plus 6 with the x and they go to subtract that. But that 6 is strictly being multiplied with that x. What is, however, being added onto this expression is this 8. And because there's no sign in front of it, it's a positive. So to get rid of it, I do minus 8, minus 8. So that'll be 6x equals 21. Then I'm going to divide by 6 on both sides. So I now have x equals, and then 21 over 6, that can't fully divide. However, I can simplify that fraction. I can divide them both by 3 to give me 7 over 2. All right, next one, I've got x's on both sides. I always prefer getting my x's to the side where it is going to be positive. So I either need to get rid of the 5x or the x. Because x is smaller, I'm going to get rid of this one. So I'll take away x on both sides to have 4x minus 2 equals 4. And then I've got that minus 2 there, so I'm going to add 2 to both sides to give me 4x equals 6, and then divide by 4 on both sides. I can't do 6 divided by 4, but I can simplify that fraction I've got going on there. I can divide them both by 2 to give me 3 over 2. And then last one on our quick recap. 3x is smaller than 9x, so I'm going to get rid of 3x. So I now have minus 10 equals 6x plus 2. Take away 2 on both sides. So I have negative 12 equals 6x. Divide by 6 on both sides. Give me negative 2 equals x. And then mathematically it's nicer to just swap it around so it's x equals negative 2. Alright, so that was our quick recap. Now let's apply some bracket knowledge to it, but the idea is the exact same. So here I've got x, close bracket, x plus 3, close bracket, equals x squared minus 6. So to start off with, I'm going to expand that bracket out to give me x squared plus 3x equals x squared minus 6. We've got an x squared on both sides. That means we can just cancel them out. So whenever you've got the exact same thing on both sides, you can just score them off. And now I can just divide that by 3, divide that by 3. And so I have x equals negative 2. All right, so the next one then, expanding those brackets out, I'm going to have 5x squared minus 4x equals 5x squared minus 20. I've got 5x squared on both sides, so I can cancel those out. So I've now got negative 4x equals negative 20. And then I'm going to divide by negative 4 on both sides. because I must make sure my x is positive. X must be positive completely on its own. So when I divide by that -4, I'm going to just have x, and here that double negative is going to make a positive, and it will just be 5. Alright, now applying some of our double bracket knowledge. And remember, when I've got square brackets, that means I have the same thing twice. So breaking apart that first bracket, and actually I'm not going to have that equal sign because it will get messy otherwise. Breaking apart that first bracket, putting the second bracket in. Ooh. Again, breaking apart that first bracket. Expanding it out, so I'm going to have x squared minus 4x plus 8x minus 32 equals x squared plus 3x plus 3x plus 9. So I'm now going to have x squared plus 4x minus 32 equals x squared plus 6x plus 9. Cancelling out my x squareds because they're on the same on both sides. So I now have 4x minus 32 equals 6x plus 9. I'm going to take away the 4x because it's the smaller of my two x's. So I now have negative 32 equals 2x plus 9. Take away 9 on both sides. So I have negative 41 equals 2x. Then divide by 2 on both sides. And then that will just be negative 41 over 2 equals x. Okay, so last question here. This one, I'm not going to go through all the expansion because we have done so many, and plus I know I run out of space if I do that. So we're just going to work through these of just like looking at how to apply the bits of the solving knowledge and what this question is asking you to do. So to start off with, we're told that they have the same area. And for part A, we are being asked to make up an equation for the pair. So for what I'm going to do, I'm going to label this as shape 1 and this is shape 2. So for my area for shape 1, remember that is going to be length times breadth because it's a rectangle. And so that is just going to be x plus 2. I'm going to leave it like that for the time being. Then my area for 2, again, it's going to be length times breadth. And one thing I forgot to say is whenever we have an expression, something with more than one bit on one side, put brackets around it. It makes life a bit easier. And again, I'm going to apply this length times breadth, which will be x minus 2, x plus 6. And so we are told that the areas are the exact same. So area 1 equals area 2. And so therefore, I'm going to just put my areas that I've just calculated equal to each other. So that is part A done. So remember, the reason why I put them equal is because we are told they have the same area. So I can put them just equal to each other. Then part B says to us to solve the equation to find the dimensions of each rectangle. So we need to solve what we have just worked out here. So I'm just going to give the final expansion answers just because I am aware I don't have huge amounts of space here, although it works the exact same way of what we just did in the previous question. So when I expand it, I will have 2x squared plus 2x equals x squared plus 4x minus 12. And so cancelling off those x squareds, so I'll have 2x equals 4x minus 12. What I'm actually going to do here, I'm going to get the x still on the side where it's going to be positive, so I'm going to take away 2x. And the reason why I do that, that's going to go to 0 because there's nothing else left there, is that when we do inequalities, they can be a bit weird when you're dealing with a negative x. So personally, I like to try getting it where it's positive whenever possible. And then I'm going to add the 12 to both sides. So now I'll have 12 equals 2x, and divide by 2. Just going to do the last bits over here. So 12 divided by 2 is 6. I'm going to have 6 equals 2, 6 equals x even. And that will just be x equals 6. So I found the value of x, but we are being asked to find the dimensions of each rectangle. So we need to apply that 6 in. So for my 1, that x is just going to be 6. Here, this will be 6 plus 2, which is just going to be 8. So the dimensions of 1 is going to be 6 and 8. Dimensions of 2, that's 6 minus 2, which is going to be 4. And here is going to be 6 plus 6, which is equal to 12. So the dimensions for 1 are going to be 6 and 8. And the dimensions for 2 is 4 and 12. Let me know if there are any issues, and good luck.